whenever PD is A f of x, y, for example, plus B of df
Sorry,
dx.
this is the general form.
No, it's just like, yeah, it's not the general form, if you want. It's just like, OD is only, or it can be like for more than one, but the derivative is only for one. But normally, since you only have, if you only have take the derivative of only one, then yeah, normally all the functions have only one variable.
Could you explain again? You mean two derivative? Should be two derivative.
الاشتقاق هنا بالنسبة لإكس، الاشتقاق هنا بالنسبة لإكس وبالنسبة لواي. الاشتقاق. الكلام كله في الاشتقاق.
Yeah, but you mean two variable. If you want variable, what's it called?
لا ممكن هنا يكون two variable بس الاشتقاق بالنسبة لإكس.
بالنسبة لي.
هنا الاشتقاق بالنسبة لإكس وواي.
Okay.
Two
variable.
only two variable.
Well, no, more than one.
Maybe more than
It's more than one.
maybe X Y Z.
Yeah, more than one.
OD is just one,
OD is only
just for
one.
X. I see. Alright.
Yeah, that's why we have this. Because f prime of x is df dx. Yes, but here we have this d, not this one. Because
Partial.
this is only one, and this is more than one. And then like, I don't know, f, there's a y,
Until O?
plus whatever. This is like a PD you want to solve.
Okay.
For example. Yeah. So, like numerically, there's different methods to solve them numerically. But we are going to just focus on this one. Yeah. I don't think you really need to know the numerical for these ones. Because really, this one, you can just forget about y and put this 0, and it becomes
ODs.
all these, kind of. Yes?
Okay.
Okay, so
Now we are
we
on
can
diminution.
start. Yeah.
This yours.
It's fine. Yeah.
Okay, so the definition of this is that is one or more equations connecting partial derivatives of one or more unknown functions. Yes. I just put f, but also you can put here f, I, g, h, all the
What is
functions. Yes.
Can you use more than function?
Yeah, more like here. I instead of f, I could put j as well. Two functions here, but just one variable.
One variable.
The important thing is the derivative. If it's partial or if it's not partial.
PD is
If
already.
it's partial, PD. If it's not partial, OD. Yes. Yes. Well, I don't think this is just theory. So just like the order of a degree, just the maximum derivative in the. For example, I think it's one example here. Random one. Well, like in this one, there's 1, 2, and 0. So these two, so the degree is 2. Because you have to take the maximum one. So this one is just one time respect to t. Here 2 times of x, and here is u alone, so it's no times. So what is higher, 1, 2, or 0? 2. So the degree of this PD is 2.
According to XX.
Yes, because you have to see the maximum, like the highest order partial derivative.
Is it the order?
Or it's called order or degree. It's the same thing.
Then you mean here partial according to considering to t.
No, this one t.
Yeah, partial u over partial t.
Yes.
Here partial x.
Here.
This way.
Yeah. So it doesn't really matter if it's t, x, or y, or whatever. You have to just look at the highest order.
Yeah.
So here the highest order happens to be with x, and it's 2. So this is order or degree 2. And then here as well you have XX, X, and YY. So the maximum is 2 because and it's in both here and here. So it's 2.
But this, yeah, this multiply.
Yeah,
How can I order
I'm just no. The order is just the derivative.
derivative?
Derivative. So
Oh, I
it's
see.
XX, X, and YY. So it's 2.
What about this? If you multiply this for derivative,
No,
derivative,
it's different.
it's different. Okay.
You cannot.
You can take an order for multiply.
No, 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 no,
I
no,
see.
no. Because one thing, this UX, UYY, it basically is. Yes, but if I write d of dx dy squared of u, then this is like u y yx, and now this is 3. The degree of this is 3. The degree of this is 2. Because here I have only one u respect to this all, one u, but here I have 2 u's.
But I think here cube.
You.
No, here
Not
3.
cube.
Yeah. So this is different. This is
Respect for x.
sorry.
Respect for x.
Yeah, respect for x and then for y and y. Alright, I think maybe I think it would be like this because you first do y's and then y's. But
And
it's
if
not really
first
bad.
y, then y, then x, or x, y, y.
Here is I think I don't really remember, but we're doing smooth functions. So for the smooth, if u is smooth,
What do you mean? It's mean smooth.
just differentiable, like really like soft, not like this, then uxy is equal to uyx. So it don't really matter the order of this in this subject because it's going to be always smooth. Yes. Okay, and then the linear part. So this bit is linear, but this bit is not linear because you have 2 u's multiplying each other.
It's not linear if you have
Non-linear.
multiply.
Because now we're just going to focus on the linearity not of x but of u.
How can I understand this non-dimensional or dimensional? Non-dimensional?
Non-dimensional.
In non-dimensional.
No, we're not talking about this.
Okay.
Okay.
But I think she mentioned in the class non-dimensional.
Maybe
Yeah, later.
later on. Okay, and so this is the first order, the general form. So you have u that depends on x and t. So the most general should be au plus b ux plus c ut plus d equal to 0. And it's first order. So
Just one derivative, first order.
yeah, first order just 1.
One,
So maximum is 1. I mean, so you have 1, you have 0,
And two
doesn't
variable.
matter,
BDs.
and PV, yes.
Oh.
And this is
And this is the general form. Yes, it's written differently, but you just have to think about this. Yeah, and now this easier. So now the second, I think this course is going to focus on the second order.
In this course,
Yes,
Yeah, you see,
because we
yes,
have
second order.
parabolic, hyperbolic, and elliptic.
Yeah, he
And
said
these
that.
ones are
yeah.
second order.
Here, introduction. What's parabolic?
Wait.
Wait,
It's coming now. And so second order. So how is it going to be second order? So it's the same. A u
X,
like b, but then the second order. So it's e miss f miss j, and you have u xx, u tt, and u xd, and that's it.
X what?
T.
XT.
And is equal to 0. Yeah. So just
Constant. Yeah. Is there constant like here?
yeah,
D.
D.
It's here, just like here the numbers are different. But it doesn't really matter.
Doesn't
Just
really.
like variables. Yeah. Okay. So now you don't really need to know exact this because this is more like theory, like PDEs. If you have, do you take PDEs?
Yeah, we have.
Okay. Are you doing it now?
Yeah.
Yeah.
Yes. Okay, so I'm sure you're going to do this because your PDEs course is divided. You also study the first order. You study it a lot, I think, and then in the second order you have also 3 sections: parabolic, elliptic, and hyperbolic section. Yeah. And you're going to in elliptic. You're going to.
Hit question.
Sorry.
He said hit question. Hit question.
Heat question.
Yeah.
Question.
Question. Yeah. Hit question.
Ah, heat,
Yeah.
yeah, but it's no like in the elliptic is the Laplace, parabolic heat, and hyperbolic wave. So you're going to study these ones. As
PDs.
In PDs.
You teach us. It's good.
Yeah, so they're going to teach you like
You teach us
why.
after that.
Okay. So yeah, because of this.
شفت مرتبطة كلها من العانة. Yeah, I explain for him.
Okay.
She said don't speak.
Oh, sorry. I said there is a relationship between PDs and numerical and
Numerical.
life. Yeah, I told
If you
him.
speak Arabic,
Yeah.
you
Of
will
course,
pay
this-
1
Yeah.
pound. 1 pound.
No, just
Perfect.
Yeah.
explain for him.
Pay for me, huh?
Alright.
So yeah, you're going to learn. I'm not going to explain you all like now because it's not important like at the moment in this subject.
I appreciate if it's important for us, for PDs.
But maybe later because I don't think
Okay.
now.
Yeah, sure, yeah.
Like I think just every time you do like a chapter or something, you say you come and we just do it all
PDs
together.
in the beginning we'll take first order,
I think so.
and then
And
we'll
then-
take this one.
yeah.
Immediately.
So like it's like 1 semester. I cannot start explaining this now.
Yeah, sure.
Like I think once you have like I don't know 3 pages or 4 pages, we can just meet and do one. I don't know.
It's good to see you.
Yeah, but the thing is that we can, depending on these variables, yes, well constants, ABC, depending of this called the determinant. So depending of the sign of the determinant, then you call it elliptic, parabolic, or hyperbolic. Yeah. But yeah, just 3 times, and that's it. But this is the introduction because now we start with numerical. So how do we, how can we study numerical methods, and then we're going to apply them in these subfunctions. So this is like something, and then we're just going to start method, and then we're going to go back to the examples. Yeah. So there's 3 different methods.
To solve numerical method.
Yes.
This whole the course, we only study this 3 months.
Yeah, I think so. And then yeah, we're just going to apply them in all of them. And that's it.
If E
And spectral methods.
is in.
Yeah. So we start with the final difference. Yeah. No, like we're going to use mostly this one. This one just a bit, and this we're not going to treat these methods in this group due to other time. So we're not going to do this. Just this one, maybe, and then later on maybe this one. Yeah. Okay. So difference, because you want to make the difference of 2 points. Yeah. So basically, what we need to do here is just make a grid. Yes. Because we're doing in the computer, we cannot save for every X and for every T because there's not enough memory on everything. It's like there's infinite numbers between this here and here. So I think it's better to discretize. So that's why we need to make just a grid. And instead of evaluating all the functions at all the points, we're just going to evaluate the functions at the intersection. Yeah. This is x and this is t. And this is both 0 and 0. And it's t0, x0. And then x1, x2, t1, t2. Yes? And this bit, we're going to make it like constant. And it's called delta d, and this is delta x. Yeah.
Okay.
Does it have to be same like delta x equal the distance between x1 and x2?
Normally yes, because
It's
it's
like
going.
h, like
I
h.
think
in
in
ODs.
here. I think she mentioned something that it's better to have the same distance, and then you just decrease or increase. But of course you can make it different. But for simpleness, just make it the same. Yeah. Okay. So we're doing the method for the how to say, for order 2. Yes.
We now focus only for order 2.
Yeah. But of course, if you have order 2, you also have order 1. You know.
Yeah.
Okay. So now, how do you define the limit? Either df over dx.
Excuse me, Carla, could you please write number, like here, number 1?
So this is from calculus. So this is the limit of x equals to 0 of f of x plus h minus f of x over h.
Sorry, this is what?
Definition of
Of, yeah.
integral, not
No.
derivative.
Yeah.
Derivative.
This is the function.
اشتقاق.
Because
Circle.
this is,
Satan.
if you are here, yeah, and your function is here, and you're at this point, yeah, this is basically the tangent. Yeah. Tangent,
Tangent.
Tangent.
just the slope, yeah, slope,
Slope.
tangent. So this is
She
basically,
can-
Same slope.
yeah. So this is
She
a,
can pronounce tangent last time, I remember.
I don't know if it's tangent, but
Yeah.
I call it
Yeah.
tangent.
Yeah, but
In
who
Qatar,
correct
so-
for it?
I don't know.
Ajay,
Ajay.
correct, yeah.
But so this is a tangent. So what you're doing here is just evaluating the function here. This is x plus h, yes. And you are doing now, this is basically this line.
Other line.
Yes. This is this one. And this is it. Yes? So if you make h small and small and small and small, at the end it's going to be like the same point, and then it's going to be
Same
made
time.
as that. Yep. So why this is the definition of this thing.
You mean the derivative? It's this line.
The derivative is the black one.
Black one.
And f of x plus h minus f of x, because this point is f of x, and this point is f of x plus h. So, yes?
When we divide by h,
Well, it's just not the number. It's going to be a smaller or bigger, you know? Just
For Riemann, it's called Riemann.
Sorry?
Riemann.
Yeah.
Riemann.
Riemann.
No, Riemann is something else.
Okay.
Yeah, so this is, and then the smaller the h is, the similar is going to be the tangent. So if you make h smaller, 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 it's going to be exactly that. Yeah? This is just the definition of derivative. This is just calculus 1.
But you forgot. Thank you for reminding us. Really.
No,
It's
no,
not.
it's just here, yeah?
Yeah, we'll get it now.
So instead of h, now we're going to have x and then x plus delta x, because we're in this grid. Yes? And it's going to be the same with the time. Yeah, but I'm not going to write it twice because x or t is the same.
I see.
It's just a variable. Yes? Okay, so now we can say that df of dx is similar to what? To f of x plus delta x minus f of x divided by delta x. Yeah, so this is similar as long as delta x is small. Yeah, because this has to be small.
Could you repeat this? Is approximate or just?
Yeah, approximate. It's just like, since this is the limit,
Hmm?
if we choose delta x small enough, then it's going to be similar.
Similar, yeah.
Yeah.
Tangent, you mean as mentioned. Okay, I got it.
Yeah, so we choose this point small enough,
We'll take
then it's
together.
going to be like so similar to
Tangent,
this one.
yeah.
Yeah.
Derivative.
Yes.
Yeah.
Okay, and then there is, let me check. Yeah. So this is one of the definitions of this.
Mhm.
Yeah, but we can also approximate this tangent with different form. How? So instead of taking, sorry, down here. Instead of taking this point, yeah, we're going to take this point. So we know that the tangent at this point is this one. Yes, this point, and this is going to be this. Yes. So and this is our x. So we can approximate the tangent, either go one step forward, yes, here, or we can go just one step backward, x minus delta x. Yeah, and what we do? So we just make x minus f of x minus delta x, delta x. So just instead of fixing this point and then moving this line, we're just fixing this point and moving this line.
And we
Forward
have
and
to make it
backward.
now. Backward and
And forward.
Yeah, so these are forward. Yeah, and these are backward.
No explain.
Huh?
Yeah. Before I don't know what they mean by
When you,
forward.
if the teacher explain like you explain, you'll understand quickly.
Why no comment?
Jeez. And 1-2 minutes,
Yeah,
you
do.
explain everything clear.
Really, it's bonus والله. I got it now.
Or I will go to manager of school, go let care the teachers.
So basically, the forward is only this bit part, so only the
Okay.
the up one. Yeah. So if you divide by delta x, you have this. So this is the forward. This is the backward. Okay.
Backward after move it like tangent to
Sorry.
after derivative, you get like if this similar, we'll get forward. I mean, if this similar, this forward.
Forward means that you're going to look at a point
At a
in
point
front
with
of
the
you,
guitar.
in front of you,
In front
and
of
then
you.
just getting closer.
Closer.
Backwards is that you, instead of looking at the point in front from you, is going to look at the point behind you
Behind
and
you.
moving up from.
This is forward.
No,
this backward.
Yeah,
And this is
forward. Yes,
forward. Yeah,
you
because
have
DH,
this,
yeah.
This forward. And because you have this.
This H or
this-
D?
No, forward and this backward.
Alright.
Okay, but then we have another one which is even better, which is called central. But I don't know why there's a beam.
Center.
You get
Center. You center now.
يا سنت بلاكورد يستخدم هذه الاساسيه دي الاساسيه فورورد يستخدم هذه الاساسيه
لأنه قال أساسي. Okay. Now the other point, center score.
سنترال سنترال
Divide.
Okay, so basically here the central one is your at x, and you're going to have x in the middle of the 2 points. So x minus delta x and x plus delta x. You have here the function, here, here, and here. Yes. Next time up. Oh, you have colors. So this is the tangent now. Yes. And now you have this. Yeah. Which I know it might be similar, but what we're doing here, let's say, this one, you're going to take this point and move it like forwards, yeah, because you're in the backwards.
Yeah.
And here you're going to do it backwards because you're in the forwards. And here, this point is going to be moving forward, and this point is going to be moving backwards.
Center.
Yes, just go into middle. Yeah, meet in the center. Yeah. So what's the forward point is this one. So it's f of x plus delta x, and now just this
Yeah.
one, f of x minus delta x. But now you have to divide by 2 delta x because you have to divide over the difference of the points. Because in here, so the difference of these two is delta x, the difference of these two is h in this case, the difference of these two is delta x, delta x. So, yeah?
The forward almost h.
Or because it's h, because it's a definition. But
Definition.
no, yeah. Because this is the normal definition. We not always normally use the forward one, but we can also use these ones. Yes?
You can use this
Yeah.
x. If you use
Yeah.
dx here.
If you take the limit, yes.
Yeah.
If you don't take it, there's this difference. Because now it's like, okay, we have three methods. Which one is better? Yeah. So now you're going to do an exercise. Because yes,
Is better.
yes, okay.
Now we have background.
Now you can stop
Why?
because you're going to do the exercise.
Solve
Solve it.
You
Sorry.
solve it. حل يعني